Hello and welcome to our review of the 2020 AMC8. Now, the reason why there's no 2021 AMC8 is simply that the contest calendar has shifted a bit, and so the AMC8, the most recent one, is actually in 2020, and you're going to have the 2022 AMC8 sometime about now actually. So for those of you who are seeing the AMC for the first time, it has 25 questions and only 40 minutes, which is why I've started a timer, which when it hits 40 minutes, I should say, we're going to start looking at the questions. Now, they are all multiple choice with 5 options, and there's no negative marking, so you are allowed to guess all the questions that you don't have time to properly attempt. For any American viewers over here, I would say that you can try looking at my other video on the NMOS, which is a Singapore contest. The time control is a bit different. It's not multiple choice, but the question type does have some overlap, right? And any Singaporeans who are trying to prepare for competitions, the AMC8 is a good practice resource. Right, and so we are coming up to about 40 minutes now, and I should begin very shortly. Let me just say that the AMC8 is basically a speed contest, so I won't be saying too much as I run through these questions so that we can actually do it in something resembling 40 minutes. Alright, question 1. So Luca is making lemonade to sell at a school fundraiser. His recipe requires 4 times as much water as sugar and twice as much sugar as lemon juice. He uses 3 cups of lemon juice. So 3 cups of lemon juice means 6 cups of sugar, and 6 cups of sugar means 4 times 6, which is 24 cups of water. And that's the speed that we're looking at for the first few. 4 friends do yard work for their neighbors over the weekend, earning $15, $20, $25 and $40 respectively. They decide to split their earnings equally among themselves. Okay, if we add this up, 15 plus 20 plus 25, 3 times the middle one is 60, 60 plus 40 is 100, 100 divided by 4 is 25. So the one who earned $40 would give $15 to the rest, to take $25 for himself. Question 3. Carrie has a rectangular garden that measures 6 feet by 8 feet. She plants the entire garden with strawberry plants. Carrie is able to plant 4 strawberry plants per square foot. Okay, so you have 6 times 8, 48, and then 4 per square foot, and 10 per plant. So multiply everything together. 48 times 4 is 192. 192 with a 0 at the back. Question D. Question 4. 3 hexagons of increasing size are shown below. Suppose it continues. How many dots are in the next hexagon? I think there's no point in doing anything more clever than just drawing the next hexagon. You just draw it carefully. The good thing is that if you look at the options, they're all odd numbers, so you do have a buffer of 2. So just in case we count something wrongly, we do have 1 free space that we can use. Okay, so the inner layer has 1, the next layer has 6, the next layer has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The outermost layer has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So this sums up to 37. There are shortcuts for a lot of these, but I think the shortcuts don't save much time, so we just use the most obvious method to us. Question 5. 3/4 of the pitcher is filled with pineapple juice. The pitcher is emptied by pouring equal amount of juice into each of 5 cups. What percent of the total capacity of the pitcher? Okay, so they're asking for percent. 3/4 of the pitcher is 75%, and so 75% got split into 5. It means that each of them is 15%. Question 6. Aaron, Darren, Karen, Maren and Sharon rode on a small train that has 5 cars that seat 1 person each. Maren sat at the last car. Okay, so I'm going to just make spaces. Aaron sat directly behind Sharon. Darren sat in one of the cars in front of Aaron. I'll put a dot to represent that. And at least 1 person sat between Karen and Darren. Okay, so you see that Karen cannot slot into here or here because she'll be next to Darren, so Karen must be here. So the only way that this can work is Darren, Sharon, Aaron, Karen, and Maren. Okay? And the person in the middle is Aaron. Question 7. How many integers between 2020 and 2400 have 4 distinct digits arranged in increasing order? For example, 2, 3, 5, 7. So the first digit must be 2. The next digit must be more than 2, but your number is at most 2400, so it must be exactly 3. So the rest of this, we just need to find 2 numbers that are both bigger than 3 and the first is bigger than the second one. How I'll do this is to just list them out. I think that's the fastest way. For 4, then you have 5, 6, 7, 8, 9, which is 5 choices. 5, you have 6, 7, 8, 9, which is 4 choices. For 6, you have 7, 8, 9, which is 3 choices. 7, you have 8 and 9, which is 2 choices. And for 8, you have 1 choice. So 1 plus 2 plus 3 plus 4 plus 5 is 15. Question 8. Ricardo has 20 coins, some of which are pennies and the rest of which are nickels. He has at least 1 penny and at least 1 nickel. What's the difference in cents between the greatest possible and least possible amounts of money? Okay, so the most he can have is 2019 5 cents nickels and 1 penny 1 cent. The least he could have is 1 5-cent coin and 2019 1 cent coin. So what's the difference? The difference is 2018 extra 5-cent coins, but 2018 less 1-cent coins. So this is 5 minus 1, which is 4, times 2018, and 2018 times 4 is 8072. You notice the 8062 and 8082, those are a bit nasty because they are just there to trap you if you make a calculation error too quickly. Question 9. Akash's birthday cake is in the shape of a 4x4 inch cube. The cake has icing on the top and the 4 side faces, but none on the bottom. Suppose you slice it into 1 by 1 by 1 smaller cubes. How many of the small pieces have icing on exactly 2 sides? Okay, so that will be actually all the so-called edge pieces, but not the corners. Right, so you have 2 here, 2 here, 2 here, and 2 here. And then you will have 2, 2, 2, and then 2 more at the back. Now the bottom, also don't forget, since the bottom has no icing, the corners will now be the ones with 2 for the bottom layer. Okay, so I know I've just done a lot of circles, but this is 8 times 2 plus 4 times 1. So this is 20. Okay, don't forget the bottom ones are a bit different since the icing is not included at the bottom. Question 10. Zara has a collection of 4 marbles, an Aggie, a bumblebee, a steely, and a tiger. She wants to display them in a row on a shelf, but does not want to put the steely and the tiger next to each other. In how many ways can she do this? Okay, so there's no harm in listing this. I think the fastest way to do this would be to just see where can you put the steely and the tiger. So you have S and T here, S and T here, S and T here, and then you can reverse it around. So there are 6 ways that you can put the steely and the tiger, and out of these, for each of these 6 ways I should say, the Aggie and bumblebee, there are 2 choices for each. So 6 times 2 is 12. Question 11. After school, Maya and Naomi headed to the beach 6 miles away. Maya decided to bike while Naomi took a bus. The graph below shows their journeys, including the time and distance travelled. What's the difference in miles per hour between Naomi's and Maya's average speed? Okay, they're only asking for average speed, so really all you need to care about is how long they took to finish. So Naomi took 10 minutes and Maya took 30 minutes. So Naomi took 10 minutes for 6 miles. You multiply by 6, it means 36 miles per hour. For Maya, she took 30 minutes to do 6 miles, means that she would actually have 6 times 2, which is 12 miles per hour. And the difference, 36 minus 12, is 24. You don't need to care about all the stopovers and all the strange kinks in the graph. Question 12. And this one's a bit interesting. For positive integer and the factorial notation, okay, so for those of you who haven't seen it before, some number with the exclamation mark, that's a factorial. It means that you multiply 1 times 2 times 3 all the way up to that number. So we asked, what value of n satisfies this equation? 5 factorial times 9 factorial equals to 12 times n factorial. So 5 factorial is actually 1 times 2 times 3 times 4 times 5 is 120. Oops. I was deciding whether to write 120 or to write the multiplication, so I guess I'll write both. So it is 120, and so 120 and 12 we can cancel off a factor of 12. So it becomes 10 times 9 factorial equals to n factorial. Now this is pretty neat because 9 factorial is 1 times 2 times 3 all the way to 9, and then you put an extra 10. So this just tells you that n is 10. So we're going through this smoothly. This is the first half and we've taken about 10 minutes. If you are doing these kinds of contests for the first time, this is really a different pace from what we're used to, perhaps because this is basically a minute and a half per question. So you do have to really go through the easy questions really fast, but go through it at a pace where you think you're not going to make too many careless mistakes. Right? So if you make so many mistakes, it's useless, but if you go too slowly, you won't even get to see anything in the second half. Okay, question 13. Jamal has a drawer containing 6 green, 18 purple and 12 orange socks. After adding more purple socks, Jamal noticed that there is now a 60% chance that a sock randomly selected from the drawer is purple. Okay, so 60% of the socks are purple after the addition, but he only added purple socks. So the 40% of the new total comes from the other two colors, the green and the orange socks. So there are 6 plus 12 is 18, and so you divide by 2, 20% is 9, you times 5, 100% is 45. Now the original total, 6 plus 12 plus 18 is 36, so the additional socks is 45 minus 36, which is 9 purple socks. Now how did he add an odd number of socks? Why would he have 9 purple socks? I have no idea. But, well, he didn't add any other socks, so 9 must be the answer. Question 14. There are 20 cities, oh this is an estimation question, and the average of, okay, so this is not really an estimation question per se because they show all these bars and I really was quite lazy to try to add them up, but it tells you that the horizontal dashed line is the average and there are 20 of them. So this is 4,000 and 6,000. There are 1, 2, 3 markings in between, means that this has been split into 4 parts. So each small marking is actually 500. Right? Each small marking is 500, meaning that this would be 4,500, 5,000 and 5,500. And this is kind of in between 4,500 and 5,000. So it looks like this one is somewhere around the midpoint, which is 4,750. Now 4,750 times 20, we just take 2 times 475, that is 950. 2 more zeros at the back, and what do we know? That is option D. Okay, question 15. Suppose 15% of x equals 20% of y. What percentage of x is y? Okay, so when you say what percentage of something is something, they are basically asking you for the ratio. They're asking you how big is one of them compared to the other in like a multiplication sense. Is it 2 times? Is it 1.5 times? So 15% of x equals 20% of y means that you can say of x is 20% of y. You can multiply both sides by 5. So 5 times 20% is 100%. And 5 times 15 is 75%. So that means that 100% of y, which is just y is 75% of x. So let's make sure we're reading it correctly. It says what percent of x is y. So y is 75% of x. Alright, so that is actually correct. Question 16. Each of the points A, B, C, D, E, F in the figure below represent a different digit from 1 to 6. Each of the 5 lines shown passes through some of these points. The digits along the line each are added to produce 5 sums, 1 for each line. The total of the sums is 47. What is the digit represented by B? Okay. So the 5 lines, we can see pretty clearly what they are. I'm going to note down how many lines each of these A, B, C, D, E appear on. So A appears on 2 lines, B appears on 1, 2, 3 lines, C appears on 2, D appears on 2, E appears on 2, and F appears on 2. So each of these contribute to 2 lines except for B, which contributes to 3 lines. Conveniently, they ask for B. So B stands out. It's a good thing. So 47 comes from having 2 of each of them. Plus an extra B. But A to F, I have not figured out which is which. I just know they are from 1 to 6. So this would be the sum from 1 to 6, which if we add up 1 plus 2 plus 3 plus 4 plus 5 plus 6 is 21. So 2 times 21 is 42. So 47 equals to 42 plus B. So B must be equal to 47 minus 42, which is 5. Question 17. How many factors of 2020 have more than 3 factors? Okay, well, let's first write down the prime factorization of 2020. Now, 2020 is 10 times 202. This 202 is 2 and 101. 10 is 2 and 5. So 2020 is 2 times 2 times 5 times 101. Now for you to have more than 3 factors, it means that you cannot have any prime numbers. It must be something like 2 times 5 or 5 times 101 or something like that. So we can start listing out which ones work. 1 does not work, 2 does not work. The next smallest is 2 times 2, which is 4. 4 only has 3 factors, 1, 2 and 4, so that does not work. 5 also does not work. And the only other one that doesn't work is 101, because that's it. Now when you take 2 different prime numbers and multiply them together, you will at least get 4 factors. You get 1, the first prime number, the second prime number, and the product of the 2 prime numbers. So that at least guarantees 4 already. That means that anything other than these ones should work, because they would involve at least 2 different prime numbers, possibly all 3. Now we can either list all the rest, or remember how we can count the number of factors of a number very quickly. The number of factors would come from adding 1 to each of the exponents, which is, this is 3 times 2 times 2 is 12 factors. So 12 factors is the total, of which these are the 5 that we don't want. So 12 minus 5 equals to 7 is the factors that we want that have more than 3 factors for themselves. Okay, so this will include things like 2 times 5, 2 times 101, 5 times 101, 2 times 2 times 5, and so on. Question 18. Now we're getting to the more tricky ones, and we have another 8 questions in 22 minutes. So for all the rushing that we did about doing at 1 minute per question, now for this last bit we have about 3 minutes per question. It doesn't sound like a lot, but it's much better than what we started with. Rectangle ABCD is inscribed in a semicircle with diameter FE as shown in the figure. You have got a 9, a 16 and a 9, which means the diameter is 9 plus 16, 25 plus 9, 34. Now when you tell you the diameter, you always must relate it to the radius. The radius is half of it, so it means that the radius is 17. Now this here is a rectangle. You want its area. You already know its base, so you want its height. To find its height, I'm going to use the fact that it is symmetric to draw a line from C to the center of my semicircle. Now I know 2 things about this. 1, because it is symmetric, the 16 gets split into 8 and 8. 2, I know the radius is 17, and so Pythagoras' theorem would allow me to find CD. If you are familiar with your Pythagorean triples, you would know that the Pythagorean triple would be a 8, 15, 17 triple. If you're not familiar, then you just have to do the calculation. Either way, it means that this height is 15, and so your area is 15 times 16, which has to end in a 0, so it has to be 240. Question 19. A number is called flippy if its digits alternate between two distinct digits. For example, 2020 and 37373 are flippy, but 3883, 123, 123 are not. Okay. So you just have two digits, you just go something like AB, 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 AB. How many 5-digit? Okay, so 5-digit flippy numbers mean something like A, B, A, B, A. That's how it must look like. You want them to be divisible by 15. 15 has no divisibility test, but 3 and 5 have simple divisibility tests. Now, for it to be divisible by 5, it means that the last digit is 5 or 0. Now, it cannot be 0 because then that would make it 0 something 0 something 0. So you can't start with a 0, so it must be 5. Now, the other thing, divisible by 3, it means the digit sum is a multiple of 3. The digit sum here, 5, 5, 5 is 15. B plus B is 2B, must be a multiple of 3. This portion here is already a multiple of 3. So it means that what is left over must also be a multiple of 3. So 2 times B must be a multiple of 3, which means that B must be a multiple of 3, which means that B can be 0, it can be 3, it can be 6, or it can be 9. So that gives you 4 options. Question 20. Scientists walking through a forest recorded as integers the heights of 5 trees standing in a row. She observed that each tree was either twice as tall or half as tall as the one to its right. Unfortunately, some of the data was lost. Her notes are shown below with blanks indicating the missing numbers. Based on observations, the scientist was able to reconstruct the lost data. What's the average height of the trees in meters? Okay, so let's see how this works. Now you have the average height being something 0.2. Let's call it n plus 0.2 is the average. Now that means that the total must be 5n plus 5 times 0.2. 5 times 0.2 is just 1. So it must be 5n plus 1. Now let's see how this can happen. Now you started at 11 here. Remember that you're allowed to either go twice or half as tall. So it means that from 11, you can go down to 22, down to 44, down to 88. You can also go up to 5.5 and 2.75. And these are your options. Now let's just try to figure out how this would work out. Now looking at all the options here, we know that it must have gone up at some point, right? So there should be a 22, 44 somewhere. And also we know that when it's 5n plus 1, what this means is the last digit is 1 or 6. Okay, so let's just write down all the things that could happen for the last digit. Right? This one can either be 2 or 5.5. Now I know I'm not saying the last digit is 5.5, but I mean everything that comes from the last digit and the decimal point I include. This one is also 2 or 5.5. This one, right, so this is able to go up to the 0.75. It can come back to 11, or it can go all the way down to 4. Now the last one, definitely I can't go up further to 1.375, that surely is wrong. So I can either have 5.5 or I can go back down to 2 again, 22. Or maybe I went all the way to 88, who knows. Now I see that the 2.75 doesn't match with anything, so if I had that, the total is definitely not going to be a whole number, so I can strike that off. So now I just need to see how can I make all of these add up to 1 or 6. This is interesting. Okay, so let's see what happens if we use the 5 point. Oh no, I'm silly, right? The question says recorded as integers. Okay, so this is not as difficult as I thought it was. I'm just imagining that. Okay, so this has to be 22. Okay, that explains it. So this has to be 22, and so does this. I don't have as many options as I think. Right? Sorry about that. And this tells you the virtue of reading the question carefully. So the last digit here is just 1 or 4, and the last digit here is just 2 or 8. That is way easier than what I was making it out to be. Right, so 2 plus 1 plus 2, the last digit here is 5. If I go 1 plus 2, that will give me 8. If I go 4 plus 2, that will work because it would give me a total of 5 plus 6, which will give me last digit of 1. So the height should be 22, 11, 22, 44, 22. The total of these ones would be 55 plus 66, 121. Divided by 5 is 24.2. You wasted a few minutes here because I read the question wrongly. So do read the question carefully, otherwise you might end up wasting some time on what I just did. Okay, a game board consists of 64 squares that alternate between black and white. The figure below shows square P in the bottom and Q at the top row. A marker is placed at P. A step consists of moving a marker onto one of the adjoining white squares in the row above. How many 7 step halves are there? So you just go up and wind all the way to the top, starting from P, and you want to know how many ways there are to get to Q. So this is a very novel way of asking a so-called counting roots problem, where you just want to start counting from here. There's one way to start here, and so there's one way for both of these. And then to get to this square, there are 2 ways. Here is 1 and 1. This is 1, 3 and 3, 1. 1 plus 3 is 4, 3 plus 3 is 6, and 3. We have 1. I actually don't need to fill the stuff on the left because they're not going to contribute, so maybe I will start ignoring them. 9. This is 19, and this is 9, and so you get 19 plus 9 is 28. Great, so that made up for some of the time I wasted in the previous question. Question 22. Okay, this is a funny one. So for those of you who have watched some math videos, you might know n over 2 and 3n plus 1 is actually related to the famous Collat's conjecture. If you have never heard of that before, not important for the question. So this machine, if it's odd and it's even, has 2 different rules. If it's even, you divide by 2. If it's odd, you take 3n plus 1, so you times 3 plus 1. So for example, if you take 7 and you put it into the machine after these 6 steps, you're going to get 26. Now when the 6-step process is applied to a different starting value of n, the final output is 1. What is the sum of all such integers n? Okay, and it's a positive integer, so it will always be positive integer throughout. You won't get a negative number or 0. Okay, so how we can do this here is to backtrack and see what it could have come from. Now 1 could not have come from 3n plus 1, it must have come from n over 2 is 1, so the previous one must be 2. Now 3n plus 1 cannot be 2, so it must have come from n over 2, meaning the previous one is 4. Now 4 could have come from n over 2, meaning 8, or it could have come from 3n plus 1 is 4, meaning this was already 1. Okay, let's backtrack. Now n over 2 is 8, means it could have been 16. It could not have been 3n plus 1 because 3n equals to 7 has no solution. The 1 we can follow again, right? 1 could have come from 2. The 2, just like what we mentioned earlier, could have come from 4. The 4 could have come from 1 or 8. So we just settle the bottom row first. Now 16 could have come from 32 divided by 2, or it could have come from 3n plus 1 is 16, meaning it could have come from 5. 3 times 5 plus 1 is 16. Now 32 could have come from 64. 3n plus 1 could not be 32 because 3n equals 31 has no solution. 5 could have come from 10. So we get 64, 10, 8 and 1. If we add them up, we get 64, 74, 82, 83. Okay, now the question says a different starting value. So I just need to make sure I didn't repeat 7, right? And none of these are 7, so we're all good. Question 23. I have 11 minutes. 5 different awards are to be given to 3 students. Each student will receive at least 1 award. In how many ways can the awards be distributed? Okay, now remember that the students are also different. So I can just call the students 1, 2 and 3 and the awards A, B, C, D, E. Now each student will receive at least 1 award. Means that there are not that many ways to distribute the number of awards, right? So either the number can be split in terms of 3, 1 and 1, or it can be split as 2, 2 and 1. So let's settle each of these cases separately. Right, now if let's say you choose to give 3, 1 and 1, there are 2 things that we need to take note of. The first is that 3, 1 and 1, there are 3 ways to choose who gets 3 awards. Now if you want to then count how many ways are there to give the awards, I can say there are 5 choices for this guy and there are 4 choices for this guy. And then the last person with 3 awards takes all the rest. So 3 times 5 times 4 is 60 ways. Now for the other one, 2, 2 and 1, there are 3 ways again to decide who gets how many awards. This time we can think of it who gets 1 award. Now for giving the awards, I can say there are 5 choices again for this person who gets 1 award. Now for the other one, there are 2 people who each receive 2 awards. I need to do 4 choose 2. Now 4 choose 2, 4 times 3 divided by 2 is 6. So 3 times 5 times 6 is equal to 15 times 6 is 90. So 60 plus 90 is 150. Sorry. Okay, so for question 24, a large square region is paved with n squared grey square tiles, each measuring s inches on the side. This looks like an optical illusion, right? You see the grey dots seem to be appearing in the middle. Okay, so a border d inches wide surrounds each tile. The figure below shows the case for n equals to 3. When n equals to 24, the 576 grey tiles cover 64% of the area of the large square region. What is the ratio d over s for this larger value of n? Okay, we need a second to try to figure out what's going on down here. Okay, so 576 grey tiles covers 64% of the area of the large square region, means that 64% corresponds to 576 tiles worth of area. So 576 divided by 64 is 9. So that means that the big square region is actually worth 900 tiles. So if it's 900 tiles, it means that the length here is 30 tiles worth of length. Now inside with all of these here, you have got 24 tiles worth of grey regions. And if you look down the column, you actually have 24 tiles plus 25 borders. Yeah, so the 25 borders corresponds to 6 tiles. And so naturally, if you see S is the length of the tile and D is the length of the border, the ratio is 6:25, which thankfully is one of our options. Okay, so last problem. Question 25. Rectangles R1 and R2 and squares S1, S2 and S3 shown below combine to form a rectangle that is 3322 units wide, it's a strange number, and 2020 units high. What is the side length of S2 in units? Okay, so there's nothing else here except for the fact that these are squares. Okay. So this is actually not as difficult as it looks if you think about the fact that we know nothing about the rectangles, we know nothing about the squares, so the only thing we can use is the fact that squares are squares. Okay, so S1, S2 and S3 here, let's just call the lengths x, y and z. So x plus y plus z gives you a length of 3322. Now if you look down here, this is also x and this is y, so this is x minus y, and similarly this is z, this is y, so this is z minus y. So if we go down, it will be x minus y, y and z minus y, which is really just x, if we look at this one, plus z minus y. So this is almost exactly the same, except one of them has a plus y and one of them has a minus y. So the difference will be plus y minus y is 2y. So 2y is going to be the difference between these two, which is 1302. Finally, if we divide, you get y is 1302 divided by 2 is 651. Great, so we actually have a few minutes extra even compared to what we planned. Okay, now let me just double check because I'm solving this somewhat live. I have of course seen the questions while copying it in, but I have not really tried them properly. So let me just check my answers very quickly. Okay, so the first 5 are ECDBC, I'm not too surprised if one of these I've done something a bit silly. Okay, the next 5 are ACCDC, okay, so far so good. The next 5 are EABDC, okay, then EBABB, and finally the last 5 are AEBAA. Okay, please be correct. And phew, okay, everything seems fine. Okay, so if you feel a bit exhausted looking at this is pretty normal actually. It's quite normal to be out of breath at the end of something at this pace. I myself feel pretty out of breath after running through 25 questions at this pace. So you should take this as a sprint, right? Something like AMC8 is a sprint. Something like AMC10 or 12 or the SMO is like an intermediate distance. Right? So you shouldn't have to speed for those, but for something like the AMC8, there is really no choice but just to speed. Okay, so with about 2 minutes left, I have nothing more to add, so I hope you found this useful. Please share if you have any alternate solutions that you think could be faster, any comments or any feedback, and finally all the best if you are taking the AMC8 either now or pretty soon. So that's it. Thanks for watching again and see you all next time.